All right, so while that story is running, I actually switched to a story that I created before just to save time. So this is exactly the same data set, the same variables, and you're going to see this is the first screen that comes back to you. And on this first page or first screen, you're going to see that we are maximizing daily quantity. We see the total rows. We see average daily quantity. We see the input variables. So again, just getting used to these terms. Um, excuse me. Input variables. These are the variables that we included in our story, in our in our data set that we are discovering insights from it and trends. And we see this thing called correlation. You can read a little bit more about it, but pretty much what, if you're not statistically oriented, what it means is the influence of this particular variable and its values on the output variable daily quantity. So in plain English is you tell me the city and I can tell you if you sell a lot or if daily quantity is high or not, just because this is a high correlation. Maybe month, yes, I can tell you a little bit, but you tell me the item and discount is just, it has a little influence, is not enough for me to, from the get-go tell you something about it. And again, revisiting the concept is this is telling me the predictive power in the future. If I were to know city and month and promotion, I probably can give you a good estimate on that daily quantity. And not only that, the city itself have a big influence on the daily quantity, according to this metric or this number per se. Now I can see here different versions because I actually run this multiple versions before. So every time you run the story, you edit anything, you can get another version and revisit the back and forth the versions. I see my top insights. So by default, I have the insights first. I can see that again, correlating to this or matching that the city is the biggest influence on the daily quantity. And I get this first insight right here. And I can see, for example, I have my cities. They're listed by the number of observations. So if I look at it from this side, New York City has the most records. So if I think about 30,000 records, out of those 30,000 records across all the cities, New York has probably, let's say here it says 3,045, right there the count. Then Miami is 3,043, so it's less. San Francisco is less or equal, then less and less. So it is by the number of observation, the count of rows moving, descending this way. We can control this by alphabetical, for example, or we could put any order we wanted in the recipe or in the data prep. And we control this when we go to the variables. But what it's telling me right now is this is the average across all of my population, all of my data set. And I can clearly see San Francisco again, Boston way above. And I see some other stores or cities way under or significantly above the average. New York is almost at the average, so it's grayed out. Nothing really, with respect to city, there's nothing to see here. So it is acting close to the average close enough to say it's gray, and the blue is actually significant difference in the behavior from the average. Again, this is just for the city. You can see all the explanations here. So what I'm looking at is not just a chart that you usually see on a dashboard, but there are actually some insights into this, which is why it happened. For example, San Francisco is 464, let's say above average. Okay, we know that it is high. But then it says this result may have been worsened by discount zero. So this is very interesting. For example, think about it this way. You are in a room in a meeting and you're saying, okay, this is what Einstein discovery, presenting to me. You tell me the city, it has a big influence. And we see San Francisco and Boston sell a lot, So for somebody who's dealing with this business, they can say like, okay, this is not new. We knew this. And again, you can look at it two ways that, well, we also just got to know it immediately through ED. We haven't been here for, months. But also more importantly, I immediately told you that this result may have been worsened by discount is zero, which means that there is actually potential to sell more, something very interesting maybe we didn't know. Or Boston is 458 and again is worsened by promotion is mail in. Now I do have to tell you folks that depending on the org you get or the data, you know which version it is, the org when you sign up, you might have slight differences in the explanations, but pretty much it's along these lines that you're looking at insights, you're looking at explanations about these insights, and these insights are ordered by the most significant or the most influential variables and fields. So and values. So what I mean, if I start scrolling down, I first take city, and then I take a pairwise. So city, specific city with a specific value of another variable, in this case month. So I'm seeing that among city, the cities of San Francisco and Boston for November, they have a significant behavior or insight that we're surfacing up here. So I can see, for example, every city, if I look at November alone, the bars, the blue bars, versus all the other months, the averages, I am seeing that consistently every city in November sells way much more as an average, way much more across every other month. So again, think about those 30,000 records. You have city. So if I take only the city itself for month November and I filter all of the records and get the averages or get that amount of daily quantity for November, I get 673 for New York, I get San Francisco, etc. And then for all the other months, if I get the average for New York City for September, December, January, February, all of these months, add them up and get the average is 300. And again, that is a significance that in November we consistently sell way much more than any other month in all these cities. And you can see the explanations here. You can click on these and get some more insights. You can actually see some math. So if I go actually back here, you can see that, okay, the total the rows right there. I can see the standard deviation. I can see the count. I can see difference from average. So those are interesting metrics just to keep an eye if you're interested in knowing some more information about the data. Just keep in mind again, some folks are more it's more easy to read the explanations here. Some folks might find it more easy just to read into the numbers themselves. And as we keep scrolling down, we keep seeing city with some other variable, the month, the promotion item discount value, that some insight that we might be interested to explore more, back to the lens, or just to bookmark. So as you can see, there's a lot of insights here. So if you are going to present this, and by the way, this is not for the end user, this is for the super user or the business scientist, and you might just want to bookmark some of these so you don't have to keep scrolling. But as we go down to the next significant input variable, month, now I see month by itself is starting a new section, and across the months, again, we saw November and December, significant behaviors. October, it's almost at the average, nothing to look at from a month perspective, and the other months are way under the averages, and I see some explanations. A big point here is this is not like your regular dashboards or lenses that you just see a chart and you keep scrolling down to see the next one. There's actually a lot of information to digest. This is where the business understanding comes into place, and you start kind of relating to these insights and saying, okay, I need to investigate this a little bit more, or you agree with it, or you take note of it, or you say, okay, no, this is not correct, or I need to go back and correct the data, or something in that sense. And if you keep going down, again, you see month with the rest of the other variables values, and now you see promotion. Okay, so promotion was number 3, and within promotions, I see mail in is way less than the average, and not only the average of daily quantity. So if I look at all the records, with mail in as a value of promotion, and I look at the daily quantity numbers, they are significantly, all of them small, and they come up to 250 versus the other kinds of promotions or values, and they have larger values for daily quantity. And there is a big message here because we know that mail-in is the number one, 17,000 right there. There's a lot of mail-in going out, and they are the least performant. So this is absolutely something to investigate. We need to know why we're pushing so much mail-in when we know that they don't work in general, or they don't have the same effect as display, which only 3,000 of them count, and so forth. So those are some interesting metrics we're going to dig into and look into. And these are all under insights, a combination of the existing historical data, what have happened, with a little bit of insights because we ran predictions and insights there. So let's say I'm interested maybe in city in particular. You can click here just to focus on city, or click here, it's the same. And now I'm thinking about cities. Okay, well, maybe let's go back to maybe San Francisco or even Boston, right? So I'm a bit interested in either of these cities. So I can say, I can go up right here and choose that particular value. Let's say Boston, for example. And now what I'm looking at is, well, okay, there's about 3,000 records. We saw that most of the cities have that similar row count. The average is very high, and we see it's almost 136% above. And we're seeing all these insights. November 12 is better. We see coupon in November does very good in Boston. December mail-in also is affecting us, and so forth. Now, but what if I wanted a little bit more, explanations? So remember, we said Einstein's discovery is not just about the prediction; it's about the explanation. So we can relate to the user or the business user at the end, like why this value is there. So let's click on why does this do better. And this is a component driver analysis chart, very important feature in the product. Even if you're not going to be using this later on for deploying predictions to production, at least as an analyst or analytics analyst, you need to be able to use this to analyze the data you're seeing at a completely different level. So what I'm trying to say here is this chart, as we expressed in the previous video, just command minus or zoom out if you don't see the explanations. And what you're going to see here is why Boston is high. We're going to try to explain why Boston is high, and that is what we're going to try to do. And remember from the previous conversation we had, the global average, that gray number, and the lowest bar, so these two bars right here, this particular one and this particular one are real numbers. If I go look at my data and my 30,000 records, and I look at daily quantity and add all of these daily quantity, divide by the number of records, which is 30,000 something, I'm going to get that number, 335, 334 point something. If I go to my data and I filter out city for a city equal to Boston, only the Boston records, and look at the daily quantity again, and add those numbers and divide by the 2,900 something records, I'm going to get that 793. So why is the difference? This is where the model, our predictive model, is trying to explain and tell us the difference. What is it that's making this jump from 300 to 793? Think about this as an explanation back into past data, but this is the same thing that's going to happen for future. That record that we created on the object, we're going to predict for Boston what needs to be done, for example, and the predicted amount. All right, so what is this exactly? So it's saying, well, this is the average in general. Because it's Boston, you get this boost. You get this boost. And this boost is, in this particular scenario, it's whatever the number is, and this is very important that we shouldn't be stuck on what is this number, what does it mean, because we look at the sum of all of these together that gives me the predicted amount for Boston. But one way, and of course you can dig into the equation of the coefficient and preclude sum of frequency, etc. It's all there defined in the help links for AD. But more importantly, just think about it as the impact, right? So because Boston by itself is hugely green, meaning, the most simple way I can think about it to explain is every time there's a Boston, the daily quantity is significantly high, 700, 600, 650, all those numbers are just high. And so Boston by itself is a good thing. That's pretty much what it's saying. It's a good thing, and is such a good thing that it gives this particular impact to the daily quantity. Then you go on and say, okay, city Boston and discount 0.1. Again, the most simple explanation, of course, statistically is a little bit different, but Boston and discount 10% or 0.1, always this combination of these two values always is associated with large daily quantities. That's pretty much what it's saying. Now, then we see city Boston and items polos. Okay, so this is not so good, and probably somewhere here there will be an explanation right there, so you can see this impact what it is, and you can dig into this. Later you can go look at polos separately and then polos in Boston and kind of do some analysis, etc. And again, we see some of these. Now this is interesting right here. Cities Boston on promotion is mail in. Okay, so we see this that also it's a negative. We know that promotion mail in is negative, and it looks like we're doing probably a lot of this here. And by the way, I'm going again through the chart. As you get used to this product, you get a tendency to just look at the chart and read the explanations or kind of analyze it. But everything I'm talking about is, it's a spit out in natural language, easy to consume. So you can see like September and promotion mail-in is 5.7 and the globally, but changes to 4.2 on Boston. Okay, so daily quantity increased by 3.693. So actually I skipped this guy. So this is the one that says cities Boston promotion is mail-in is negative. We know that, and it should be actually listed somewhere here. So cities Boston and promotion mail-in led to a decrease of whatever 189, because we know mail-in is bad. We saw it in the data. We saw that mail-in is one of the most things we do as a promotion, but it doesn't lead to a good daily quantity. However, what was this that I kind of skipped to here in September? Well, if you look at it in the chart, it's right here. And this is giving me a green boost, actually. So how come mail-in here is negative and here the same thing mail-in is positive? Well, let's read the explanation. And this is one thing you're going to be hearing a lot with Einstein discovery, which is mail-in is in general is negative. We agree on that. And usually across all of my data set, or specifically here for this particular for Boston is 5.7, let's say. But it changes 4.2, let me rephrase that. For any time there's a September and a mail-in, it's it's a negative thing. We know that. So across the global data set, this whole data set of daily sales, remember, I have months and I have city, let me put here daily promotion. So I have month, I have promotion, I have city. Every time there's a September and a promotion mail-in, every time there's September mail-in, I'm looking at the daily quantity and I'm determining that, okay, well, in general, that combination, I know mail-in is bad, but the combination of mail-in, September, and mail-in general is 5.7 of the global, not Boston, so it is the global data set. And September and mail-in general, or mail-in September in general is bad. But for Boston, just specifically for Boston, that combo of September and mail-in goes down to 4.2. So we're doing, actually in September, we're doing less mail-in for Boston specifically, which is giving it a positive boost. So to repeat this, you might hear a lot of folks saying, less of a negative thing is a good thing, is a positive thing, right? So this is the concept what we have here. So you will hear people say, so if we do something that's positive, we do it more in a certain month, and that should give me a positive. If something is negative, like mail in, and we're doing it less in September for Boston, then that gives for Boston a positive boost of this little number right here. So I hope that kind of explained this use case. We will see this use case several times. And this is very interesting because it gives you that particular insight where you might not be able to see it easily from a dashboard or etc. And I do want to go, let's say, the unrelated small contributors right here. So these are too small to list, else we will end up with a long chart right here. So we kind of bucket them all under this one. And there is this unexplained. So the unexplained is like I expressed in the other video. So unexplained means that just the model is just not able to explain why exactly this is 793 versus the average being 335. And put in simple term, that means the model is not overfitting. It doesn't have an answer. It doesn't have a prediction exactly for every case, for every combination of all of these variables from these 6 fields. And this would be the quick walk through that component driver analysis.